do that. There we go. So welcome. Can y'all still see my screen? I hope so. I hope so. Excellent. Well, my name is Whitney or Whit. You can call me either of those things. I've been a GMAT and a GRE instructor with Manhattan Prep since 2010, which is crazy. And tonight, coming to you from Durham, North Carolina with my 3 crazy dogs, we are going to be covering number properties. So the concepts of positives, negatives, evens, odds, divisibility, and prime. Great question came privately to me in the window, which is, will we be sending you a recording? We don't send out the recordings. We do you one better. We post them on YouTube. So we have about, I think at this point, better part of 70 hours worth of free prep hours available on our YouTube site. You can kind of follow us. The link should be right below this recording once it's online. But we've got everything from essays to everything in verbal, everything in quant, from I'm brand new to the GRE and know nothing about it, all the way through I've been studying forever and I really want some work on this very specific topic. So please teach me combinatorics, right? We've got the lessons across the gambit. So by all means, join us for any of those free prep hours. And if you want some help getting your vocab practice to be more engaging, if you check out our main page, you'll also find like 300, almost 400 words that we've created little free videos for, and they're about 45 seconds each, and they're hilarious to help you memorize all of the GRE vocab words that you need for free, also on our YouTube. So hooray, hopefully we'll see you around more of our YouTube shows. All right, tonight, we are going to be doing problems that come from our 5-pound book, which is available. You can get it from us, Amazon, all over the place, right? Pretty much any website, book retailer. So we will be using questions exclusively from, well, for the most part, from the 5-pound book. A few of them from our major course guides, but most of what you'll see will be in this 5-pound book. Now, we're going to start with a little bit of a quiz to get warmed up on this concept of number properties. And so I mentioned this kind of briefly, but number properties on the GRE is this idea of the like qualities of a number. So what is that number divisible by? So we start to look at like divisible, divisibility, primes, and remainders. Right? So it's like one big concept, like how do I break a number up into its parts? But we've also got the concept that like builds from divisible about even versus oddness of a number, or for you like computer science folks, like the parity of a number, whether it is even or odd. Then we've also got the concepts of positives and negatives, like what would make a number, like what are some of the qualities of positive numbers, what are some of the qualities of negative numbers. And then if you're ever looking in our guides, we often include exponents and roots in that, but we won't be doing much in terms of exponent root rules this evening. Primarily, we're going to focus on these concepts of divisibility, prime, remainder, positive, negative, even, and odd. So I'd like to throw a little bit out there to start with, just a little bit of some quick quizzes. So what are some, or sorry, I should ask, like, what are the positive even numbers, right? So what are the positive even numbers? So start to list them out for me. What are the positive even numbers? Yeah, 2, 4, 6, 8. Can even numbers be negative? What do y'all think? For sure. Yeah, totally. For sure. They can. Turns out they can. So we can go the other route of -8, -6, -4, -2. Oh, but what about 0? Because I know my odds, right? My odds, the rule of odd is just that it's like not even. So 1, 3, 5, 7. And then the other side of things like -7, -5, -3, -1. So where does 0 go? Yeah, it's like, wait, hold on. Yeah, so here's the deal. 0 is neither positive nor negative. So if we were to look at a number line, which can be a really effective tool, just in general, if we were to look at a number line where someone drew a 0 that didn't look all like crazy like the one I just did, but if we were to do a number line, everything to the right of 0 on that number line is positive. That would be integers, whole numbers, decimals, right? All of that's to the right. To the left of our 0, all of our negative numbers. And then, picking in the middle, we got 0 in the middle. It doesn't go anywhere. Right? It is its own positive, negative, 0. But I love, someone said this in the window, James, so good. 0 is evenly divisible by 2. And so it turns out that the definition of even comes from a divisibility rule. That the definition of even means divisible by 2. Okay, so any number that I could write and say, all right, I take that number, I punch it into my calculator, I divide it by 2, so long as an integer spits back out, that number is even. In other words, any number that can be written as 2 times some integer, some whole number, is also an even number. This is an even number. Well, I can divide 0 by 2. I can also say 2 times 0 is 0, which means 0 is an even number. Although it doesn't always feel like it. It seems kind of like weird. We don't want to throw it there, but it is. 0 is even. It is not odd. So when we start to talk about divisibility, primes, and remainders, let's add another layer on top of this, right? So when something is divisible, it means that when we do the division, an integer spits out. So when we start to talk about even and odd, even numbers are divisible by 2. The definition of an odd number is not divisible by 2. It is a requirement in order to be even or odd that a number be an integer. That's a requirement. So if I tell you that a number is odd, I am also telling you that that number is a whole number. It's an integer. Now, for those of you like sort of mathy folks, technically whole number and integer, not the exact same thing, but for our purposes here, you can think about them in the same way, right? Like whole numbers, integers, positive, negative, things that we don't have to write with some like decimal. Okay, prime numbers are the way that we break numbers down. And if we can't divide, if we can't break something down completely, we end up with this concept of a remainder, like a leftover. So one of the things I want us to start with is a bit of a like know the code quiz. So when it comes to number properties on standardized tests, this is the least math that a math section could possibly get. And it's because divisibility, primes, evens, odds, positives, negatives are more gamey than they are mathy. And I say that because I want to recognize when I'm dealing with number properties so that I can immediately kind of like shift my thinking from, all right, what are the algebra rules? How do I write an equation? And instead think, all right, well, how can I kind of poke at this puzzle? How can I think about this game? Because that's really what divisibility is. I'm looking for patterns. I'm looking for like kind of a like gamey puzzle solving. So we're going to start with what we often call know the code. So on the GRE, the code is basically the test writers telling you something without actually saying it. And most of the time, they're telling you something very simple, but they're either using a lot of words to do it, or they're giving you like a really weird format. So for example, this little statement here, right? If A and B are integers, whole numbers, and the sum of them is even, then what would their product be? If the sum is even, what would their product be? Is it even? Is it odd? Is it, who knows? Could be even, right? What do you think? I got lots of people saying even, lots and lots and lots of people. So what are the scenarios? In what scenarios do I get A plus B as an even number? So I could, come on, put in the message 4 plus 6 would give me 10. So it could be the fact that I have an even plus an even. So 2 plus 4 is 6. That gives me an even. Haha, but I'm getting lots of like 3 and 5, 3 and 7, 5 and 7. If I add an odd plus an odd, That's also going to give me an even. Okay. Little note on test day, if I'm writing the number 0, I will write it with like a 0 with a line through it. The reason is that when I just put a little O somewhere, I mean the letter O for odd. And that's just like my convention because I don't want to confuse whether I wrote a 0 or the letter O. So if I'm doing just like a plain 0 sitting all by itself, then I do the little line through it. But I'll try and make it more clear in our work. But what this means is that the sum of these two numbers is even. What would then happen to my product? Well, if A and B are both even, an even times an even is going to be even. But an odd times an odd is going to be odd. So it turns out in this case that they could be either. Either is acceptable here. All right, let's try another one. Let's see. Send it to me in the chat window. X is an even number. Y is an odd number. Z is also an odd number. Then Z times Y plus X. What number is that going to be? Plug through that one for a moment. I love very much the like odd, lots of odds. So we're gonna go step by step. All right, Z is an odd number times, in this case, Y is an odd number plus X is an even number. Now, you don't have to memorize these rules. What's true for one odd number is true for all odd numbers, and what's true for one even number is true for all even numbers. So I might replace this with 1 times 1 plus, and if you don't feel safe using a 0, you could say like 1 plus 2. And so this is 1 times 3 is, oh, the whole thing is in fact going to be odd. Whatever you put together totally works. All right, let's try another one. What do I know? If the sum of two integers is positive, the sum of two integers is positive. Nice, y'all. Nice, right? If the sum of two integers is positive, then at least one of those numbers is positive. Absolutely. So it could be two positive numbers. That would definitely give me a number greater than 0. But I could get a situation where I have, and maybe I'll put little parentheses around it, where I have a positive and a negative, or the other way around, you know, like a negative and then a positive. I could have a situation as long as the positive thing had a bigger magnitude, was further from 0 than the negative thing, I'm going to get a positive. And so back to that weird number line thing. Let's say I have, this is 0, and I have A over here, and I have B right here. The sum of them would still be positive because the positive thing is further from 0 than the negative thing. So at least one of them has to be positive. In other words, they can't both be negative. I can't make the sum of two negative numbers give me a positive number. Okay. Let's step up our challenge, shall we? If p to the x is negative, so a little bit of exponents rattling in here. P to the x is negative, then what must be true about p and x respectively? I've got some stuff coming in. I love what I'm seeing. I love it. Yes. So notice that this isn't necessarily algebraic. This is the GRE telling you some like complex piece of information, and what you're trying to extract from it is a simple understanding of those numbers. So if I were to think about raising a number to a power, so I got this little base and I'm going to raise it to a power, and I need the whole thing to come out negative. Then I have to start with some sort of negative base, because an exponent never turns a number negative. If anything, an exponent could make a number positive, because every two negatives, so if I had like -2 squared, that would be -2 times -2. And -2 times -2 is going to be +4. Okay, so I need to make sure that I don't put any even powers up here. I'm going to put an odd power up here. And then I'm going to have to start with a negative number. So exactly right. I know that P is going to be negative and X is going to be odd. P is negative and X is odd. All right, let's try another one. What does this one mean? Nice, I love it. If M is an integer that is not divisible by 2, then by definition, it has to be odd. And a great question about the previous one. X has to be odd because in order for P to stay negative, and I should throw in here. No, this is true. This is true. P has to be a negative number. P has to be a negative number. And I need, in this case, so notice if the exponent is, so it could just be negative to make it a fraction. So if I have, remember we're thinking positives, negatives here, right? So if I've got P as a negative number, so let's say -3, I can't, like, let's say I was going to make this like -3, the negative third power. This becomes 1 over, or let me make it even actually. This becomes -2, let's call it that. Right. This becomes 1 over -3 squared. Yeah. So 1 over -3 squared is just 1 over 9. So it doesn't matter if this is positive or negative. It just can't be even. I need it to stay odd so that it lets that negative P keep its sign. That's why. Cool. All right. I love it. I love it. Let's try another. All right. What do y'all think about this one? If B is equal to 2K plus 1 and K is an integer, then what do we know about B? So good. So it turns out the definition of an even number, the like official definition, right? Mathy definition of an even number is 2 times K, where K is an integer. And so the definition of an odd number is 2K plus 1, where K is an integer. So it is the formal definition. So anytime you see 2 times a variable, I want your brain to think like, oh, I wonder if they're telling me that number is even. So in this case, 2K plus 1, this is going to be an odd number. Okay. What about this? What do I know about all prime numbers bigger than 2? Yeah, they are odd. Turns out that 2 is our only even prime, and it's our smallest. Okay, so 1 is not a prime. The prime numbers are 2, 3, 5, 7, 11, 13, 17, and so on and so on and so on and so on and so on. Okay, let's try another. If J has precisely 2 factors, exactly 2 factors, And in order for a number to have factors, we're essentially saying that that number is an integer, and its factors would also be integers. So if a number has precisely 2 factors, then those 2 factors would have to be itself and 1, which I love what I'm seeing in the chat window, makes it prime. Absolutely. It makes it a prime number. So if we break apart a few numbers just to see, 1 is not a prime number. Nope, 1 is not a prime number. 2 is the smallest. Yep, how many factors does the number 6 have? I love that. Somebody said, well, what about 6? How many factors does the number 6 have? Yeah, it's got 1 and 6 and 2 and 3. So it's got 4 factors. So if we start to break down any number, there's 2 ways to break down a number. We can break a number down into its prime factors. So for example, if I wanted to break the number 6 down into its prime factors, it would be a 2 and a 3. Those are its primes, right? So in other words, like the number 12 would break down into 3 and 4, 2 and 2. We call this a factor tree. We don't include 1 as a prime because it wouldn't make any sense in our factor tree, right? Because like I could do this forever, right? Like this is 1 and 2 and 1, right? So we don't include 1 in the universe of primes because you don't need it. Okay, so the prime factors of 6 are 2 and 3. The prime factors of 12 are 3, 2, and 2. Yeah. Okay. The factors of a number are not the same as their prime factors, although their prime factors are factors. So the factors of 6, I actually kind of think of this as factor pairs or kind of like a ladder as opposed to a tree. So 6, we always start with 1 and itself. And then from this one side, I'm just going to count up. So the next thing that is a factor of 6 would be 2, because I can take 6 divided by 2. And 2's partner would be 3, because it's 2 times 3. So if we do the same thing with 12, we'd start with the number in itself. And then I know 12 is divisible by 2, so that's a factor. So 2 and 6. 12 is also divisible by 3, so that'd be 3 and 4. And now I've kind of I've already listed the next one. I've listed the 4. So an easy way to keep track of the number of factors is to list them out. All right. Most numbers have an even number of factors. The vast majority. Right? Not primes. So we're not looking at primes right now. We're just talking about any factors. So the vast majority of numbers have an even number of factors. It's either that they're a prime number, like 11, that has only the 2 factors, or they're what we'd call a composite number, meaning that they have more than just primes. So in the world of primes, the opposite of prime is composite, basically. It means it's got more pieces in it than just its own prime. There are, however, a handful of numbers that have an odd number of factors. So think about this for a minute. Like when I'm listing out the number, right? So let's imagine, I don't know what this number is yet, but I list out the number and I start going and I'm like, okay, well, it's divisible by 1 and itself, whatever that is. And then maybe it's divisible by some other number and whatever its partner is. But then there's this solo number here. Like everything else is like a number times itself, or 2 times 3, 2 times 6, 3 times 4. What would get me this one weird, unpartnered factor? And it's perfect squares. So another fun little code is if the GRE says something to you about a number having an odd number of factors, they just told you it was a perfect square. Only perfect squares have an odd number of factors, not prime factors, factors. So you can test it out with numbers like 16, 1 and 16, 2 and 8, and then there's that 4 and 4. 9 is 1 and 9, and then 3. You can try it out with a bunch. Cool. So if J has exactly 2 factors, then J is a prime number. Y'all are doing so good at this quiz, by the way. Okay. One more. The lone story problem on the screen. One more. What do you think? in a class of P students, if that class can be evenly divided into 5 groups, then what do I know about P? Yeah, it could be either, right? It could be 10 students or 5 students or 30 students or 35 students or 100 students or 500 students or 505 students. What's true about all these numbers that I'm listing out? What is true? They could be odd or even. They are all divisible by 5. Love it. Exactly. So in a class, if a class of P students can be evenly divided into 5 groups, then P is divisible by 5 or a multiple of 5. No, in fact, we are about to see, thank you for your question, Samuel. Samuel asked, are these questions typically multiple choice on the GRE? Nope, they're across the gamut. They're all the things. They're fill in the blank, they're QC, quantitative comparisons, they're the multiple choice, what's known as DQ. It's a little bit of all of them. Little bit of all of them. So that's what we're gonna do. We're gonna try some. Who's excited? I'm excited. Y'all excited? You ready to try some real problems? I'm gonna take that as a yes, even though you're all sitting there quietly. I'm gonna take it as a yes. All right, so here we go. This is your first problem. We'll take about a minute to think it through. Normally you'd have about 2 minutes to work on it on test day, but since we were just covering a lot of these topics, I want you to see if you can maybe get to an answer in under minute 15. All right, I'm seeing some answers coming in. So in order for 65, and we want positive, in order for 65 over x to be an integer, it means that 65 has to be divisible by x. So it's a fancy way of saying, what are the factors of 65? How many are there? So I want to think through all of the factors of 65. Notice that this says 65 divided by x. So this isn't necessarily primes. This is all factors. And so 65 is divisible by 1 and itself. I can also tell it's divisible by 5. And it's going to be 5 and 13. And then there's nothing else because 5 and 13 are both primes. And so I can't, there's not going to be any like 6s, 7s, right, floating around in here. And so these are the 4 positive integer values of x that would make this an integer. Make this an integer. Okay, let's then try something that looks a little bit like that last question that we saw. I'm going to set a timer for y'all counting up. We're looking for an answer in under 2 minutes. Awesome. I'm starting to see a good number of answer choices coming in. Don't forget that on the GRE, you do in fact have a calculator, right? So when in doubt, right, you can always like toss something in the calculator if you aren't sure. All right, so lots of different answers coming in. So let's think about the story. We saw before that if I were going to take a group of students and split them up, that was divisibility. Right? That was this kind of conversation about divisibility. So if they said the number of students who attend a school bus could be divided among 10 buses such that they each have an equal number, that would mean that whatever this number is, so let's call it n for number, that number has to be divisible by 10. Meaning if I took n and divided it by 10, I'd get an integer. And the same thing is true. I'd also have to be able to divide it into 12. I'd have to be able to divide it by 16. And the question doesn't say like, what is a possible number of students? It says, what is the minimum number of students? So when in doubt, you have answer choices. And with A, I know that I could divide 120 students across 10 buses. There'd be 12 students per bus. And I know I could divide 120 students across 12 buses because there'd be 10 people in each bus. The question is n over 16 an integer? And so I could literally just test it on the calculator. And the answer is no, because I can't cut people in half. Frown on that. So I'm going to take A out. All right, let's go with 160. I know that I can divide up 160 people into 10 because there'd be 16 people per bus. And across 16 buses, there'd be 10 people per bus. The question would just be 12. So 160 divided by 12 is not a whole number, right? We get 13.3, still can't cut students in half. So my next question is, all right, 240 I know is divisible by 10. I know that. Right? I can divide it across 10 buses. And I can tell that 12 is, but if I want to confirm it, I can just double check and say, yep, okay, it is in fact divisible by 12. So last but not least, I just have to check, is it divisible? If I could type all my numbers, is it divisible by 16? And the answer is yes. Yes, it is. Correct answer C. Now, let's imagine that some of these numbers, like I was kind of like running into issues. I might want to at least just understand on review how I would know. So in order for the number 120 to be divisible by 16, for example, it would mean that all of the factors of 120, so if I were to come over here and say, 12 and 10, this is a 2 and a 5, this is a 4 and a 3, and this is 2 2s. So all of the factors of 120, which turn out to be 2, there's 1, 2, 3 of them, 3 2s, 1 3, and 1 5, all of those would have to cancel out the 16, which is 4 and 4, or 4 2s. Would have to cancel out this 2 to the 4th. The problem is that it doesn't cancel out a 2 to the 4th. There's not enough 2s in the numerator to cancel out this 2 to the 4th. And so when we start to get into more complex divisibility and number properties type problems, you might have to understand the theory behind what makes something divisible or not divisible. So in this case, 120 wouldn't be divisible by 16 because there's just not enough of those of the 2s in the numerator to cover it. But again, when in doubt, particularly for things like divisibility, throw it in your calculator. You don't have to memorize it. You were given a calculator for a reason. Okay, so let's try this one. N is a number that is divisible by both 14 and 3. So usually in these cases, when I think about divisibility, I want to think about like, what's the smallest possible number? Because the question then says, which of the following statements must be true? And typically in the world of divisibility, the smallest thing I come up with is going to be my limit for my must be true. So let's think about it. If n is divisible by 14 and 3, so n over 14 is an integer, and n over 3 is also an integer. Cool. Let's see which of these A, B. So we'll just call these like A, B, and C. And you can tell me which ones you think must be true. Nice, y'all. I'm getting a lot of answers very, very quickly. So in order for n to be divisible by 14, right, kind of what we were looking at before, n has to have all of the pieces of 4 to cancel, and that would be a 2 and a 7. So I know that the n has to have a 2 in it. It also has to have a 7 in it. But it's also divisible by 3, which means n has to have a 3 in it. So any number that would be, like 2 to the first, 3 to the first, 7 to the first, could absolutely be divided by 14, or it could be divided by 3. Either of those would be fine. So this is the minimum possible value of n. I could throw more stuff in there, but it has to have a 2, a 3, and a 7. It has to have those things. Okay, so if n has to have a 2, a 3, and a 7 in it, then it is not the case that n would have all of the pieces of 12. We saw before that a 12 is 2 2s and a 3. This only has 1 2 for sure. It might have more, but in this case, it's only got the 1 for sure. So I can't guarantee that n is going to be divisible by 12 or have a factor of 12. I can guarantee that it will have a factor of 21 though, because that's that 3 and that 7, absolutely. And n would be divisible by 2 times 3 times 7, which is the 21 times 2 is 42. So in fact, n would also be divisible by or be a multiple of 42. So B and C would be the two that we would choose. All right, so lots of divisibility. Let's look at let's change things up a little bit. Let's change things up a little bit. I'll pull that one back up in a minute. Aha, I love what I'm seeing. I love what I'm seeing. So lots of D here. Where it's like, well, hold on. Couple of things I want to take note of. So I'm looking for the clues in a problem that tell me that the GRE is testing number properties rather than algebra. Like, I don't want to see this and think, oh my goodness, this is quadratics and inequalities. This is crazy. It's not. When we see this inequality relative to 0, that's a big signal that we're dealing with positives and negatives. And in fact, if I already know I'm dealing with positives and negatives, dealing with squared things can also be really useful. It can also be really useful because squared things are always going to be positive or 0. So if my x and y, right, this side is going to be greater than or equal to 0. Because I could have an x and a y that when you add them together, like perfectly kind of cancel to 0. But quantity B is going to be at least 0 or greater. If I could show that quantity A was going to be negative, I could show that it would always be, like, A would always be smaller. But in this case, X is a positive number minus Y is a negative number, which a positive minus a negative, those things would turn positive. So this whole side's going to be positive. Now, again, they could, right, like sort of cancel each other out, but who knows which one's going to be bigger, right? We don't know which one's going to be bigger. That said, if I turned these around, right? So if I turned my little inequality symbols up here around, let's see what happens if I now say that X is a negative number and Y is a positive number greater than 0. What would happen? What would happen? Now X is the negative number. And we're going to subtract off a positive number. So you can plug them in like -5 minus 4 or -2 minus 10, or whatever the case may be. What's going to happen? What's the solution? Which quantity is going to be greater? A, B, are they going to be equal or are we unsure? I got one answer. Awesome, y'all. Yeah, this number over here is always going to be negative, which will always be smaller than 0 or greater. Always be smaller than 0 or greater. Cool. So let's look at another one. Here we go. Give this one a go. Nice, y'all. Coming in quickly. What do I know? Well, if I see an inequality relative to 0, I know that I'm dealing in positives and negatives. So let's start to chart through some of our scenarios, which can be a really effective way of handling positives and negatives. If A times B is positive, what in the world does that mean about their signs? Are they both positive? Yeah, they have the same sign. So it's either the fact that A and B are both positive or A and B are both negative. All right, now let's throw Z in, or C into the mix. I know that B and C, when I multiply them times one another, are negative, which means they have the opposite signs. So when B is positive, C is negative, and when B is negative, C is positive. So what do I know about A times C? In both cases, A times C is a positive times a negative, which makes quantity A negative. I'm going to compare that against this lovely and simple quantity B is 0 and show that quantity B is always going to be bigger. Always going to be bigger. And the difficulty is a mix for these, for sure. For sure is a mix. Let's step it up. Y'all, let's try another one. And try another one. And yes, this type of problem would be the first problem we saw that we practiced was a fill in the blank. Was a fill in the blank. Little bit trickier, huh? A little bit trickier. So I know they're talking about like evens and odds, and now we've got remainders and divisibility. So I need to think. This is a bit of a game. So for the product of positive integers f, g, and h to be even, what do I know? For the product of these, for three numbers, I multiply three numbers together. In order to get them to be even, what would have to be true? Yeah, at least one of them is even. They don't all have to be even. Any single even in a product would make the whole thing even. So I could have an even times an odd times an odd, or I could have an even times an even times an odd, or I can have an even times an even times an even, right? Like all of those. And a great question, like, should we plug in hypothetical numbers? For sure, especially if you're just trying to like think through a possible case. It can always be good to test out a number to show like, oh, this is what's true about evens, this is what's true about odds, and so on. So the product of f, g, and h is going to be even. So I know one of them's even, at least. It could be all of them. Who knows? But f and g alone are odd. And if I now know that like any even number in the mix makes something even, then it means that f and g are both odd numbers. It's got to be an odd times an odd. But in order for FGH to be even, then it means that H is the even number. So if I take F and I divide it, an odd number divided by 2, what's the remainder going to be? What's the remainder? Yeah, it's going to be 1. All odd numbers divided by 2 have a remainder of 1. But H is an even number, and all even numbers divided by 2 have a remainder of 0, which makes quantity A. So definitely like all over the place difficulty levels. This one's a lot harder than some of the other ones that we've seen. Okay, what about, we got a couple more up my sleeve. Which of these? And it's all that apply. And you will get scratch paper, by the way. If you're taking it at home, you'll have to use a whiteboard, dry erase board, but you can use that. All right. So a few things. We can start plugging in numbers, but I will say if we can think about bigger and more generic cases, we're often going to be in better shape. So in order for the sum of two numbers to be odd, there's a mismatch. So it's when we have like one even and one odd, that sum becomes odd. So my options are that AB is an odd number, whatever that is, and C is the even number. Or AB is the even number, and therefore C is the odd number. Now, let's further parse out what that means for AB, right? So now let's say A and B. If the product AB is odd, then those two things are both odd. So it's got to be that A and B are both odd. So anytime C is an even number, A and B are both going to be odd. Now, in order for the product AB to be even, there are a lot of cases. It could be that they're both even. It could be that only one of them is even and the other way. So lots of different possibilities. Now notice this says which of the following must be true. Must be true. So let's start, I think, with the easiest, which is a product. So I'm going to look in all of these cases. So these are, and I'm going to finish writing these out. These are the 4 different scenarios that could be true. Right? These are 4 scenarios. So A times B times C, well, that's this right here. A times B times C, that's an odd times an even or an even times an odd. C is always going to be true, no matter what. So now the other 2. Is it true that no matter what happens when I add A and C to each other, that I get an odd number? Well, I definitely get an odd number in that case. And in that case, and in that case, like 2 plus 1, 1 plus 2, 1 plus 2, but not in this case. In this case, odd plus an odd, 3 plus 3, would give me 6, would give me an even. So A doesn't actually have to be true. All right, let's do that same test then with B. Now we look at B times C. And 1 is even. Oh, but these 2 could be odd at the same time. These could be even and odd. So there's actually a situation where that one fails as well. The only one, y'all wanted some hard ones, the only one that has to be true no matter what is C. The only one is C. Because there are scenarios where the sum of A and C or the sum of B and C aren't necessarily going to give me an odd number. Aren't necessarily going to give me an odd number. Cool. All right. Very nice, y'all. That was like a stupendously difficult one. Let me throw one more just so you can see how these sort of turn up in strange scenarios, like how else these might show up. We'll do one more and then I'll take some Q&A and we'll go today. Very nice. So I know this one wasn't the crazy hardest one that we've seen, but I wanted you to see how often the concept of even and odd can turn up with like exponents when what they're really trying to figure out is sign. And so if Q is an odd number, -1 raised to an odd number is going to stay -1. But an odd plus 1 is going to be an even, and -1 raised to an even power is going to be +1, and therefore quantity B is bigger. I have seen this exact same thing offered up as -1 to the 2k and -1 to the 2k plus 1. So -1 to a even, -1 to an odd. Right. So these can start to show up in layers. If you would like more practice, our 5-pound book has several chapters of divisibility, primes, numbers, and number properties problems. So positives, negatives, divisibility and primes, evens and odds, and some intermixed with exponents. If you have not yet, you should absolutely come to our site, access our like a free GRE prep like practice test. And in fact, we have just recently started to launch like access to all kinds of other free resources on our site. So by all means, sign up for a free practice exam. You can sign up to attend any of our session ones for a full course for free. So you can come hang out, learn all kinds of things about quantitative comparisons, about vocab and reading comprehension. Otherwise, right, you're always welcome to join us here on YouTube, right? Check out all of our other videos, our free prep hours, our vocab flashcards. We have a ton of stuff. And then hopefully we will see you at the next free prep hour. It should be just in another few weeks. Thanks to everyone. I had one question in the chat window, so I'll answer that momentarily offline because that was more of a personal question. And otherwise, bye y'all. Have a wonderful, wonderful, wonderful rest of your late spring here in North Carolina, or depending on where you are, early winter. Have an afternoon. It was nice to get to meet and work with all y'all.